All right, so good morning, everyone. Good afternoon. So today we'll have graphing quadratic functions in standard form. That standard form is y, go back. It's y equals ax squared plus bx plus c. So if you remember, our previous lesson was graphing quadratic functions in a vertex form. That is y equals x open parenthesis x minus h squared plus k. Now we are already in a standard form. So let's just have a quick review on quadratic functions. Now, standard form, the standard form of a quadratic function is y is equal to ax squared plus bx plus c. The parabola will open up when the a value is positive. If your a is positive, and that is a is greater than 0. The parabola will open down when the a value is negative. So you have there a is equal to 0 and your parabola, it should be facing downward. Okay, here. That is going down. Our vertex is here. Alright. Next. So the line of symmetry or axis of symmetry are the parabolas. If parabolas have a symmetric property to them, if we draw a line down the middle of the parabola, we could fold the parabola in half. So like this one. Draw a line down the middle of the parabola. That is your axis of symmetry or line of symmetry. And that, we call this line the line of symmetry. So if we graphed one side of the parabola, we could fold or reflect it over the line of symmetry to graph the other side. So just like this, and we'll have a line of symmetry, and we will just reflect it to have the graph of the other side. So the line of symmetry always passes through the vertex. Now, Now, how do we find the line of symmetry or axis of symmetry? So when a quadratic function is in standard form, this is our standard form. Okay. Our standard form for quadratic equation, it's y equals ax squared plus bx plus c. The equation of the line of symmetry is x is equal to negative b or 2a, or this is best read as the opposite of b divided by the quantity of 2 times a. So let's have an example to that one. Say, for example, find the line of symmetry of y is equal to 3x squared minus 18x plus 7. So using the formula, you have there, this one, negative b and our negative b is here. That is 4. The opposite of b What's the opposite of negative 18? That becomes positive 18. That explains why it has 18 in here. Next, you have 2a. Alright, there is a problem in the presentation. Let me just correct that one. So you have there, our a is 3. So therefore, 2a is 3. Now we have placed 3 as our a. Let us now solve the problem. That is 18 divided by 6. We have there, sorry, 18 divided by 6, that is equal to 3. So our x now is, or the line of symmetry is x is equal to 3. Now, we are already done with the line of symmetry. Let's go to define in the vertex. Now, we know the line of symmetry always goes through the vertex. So thus, the line of symmetry gives us the x-coordinate of the vertex. To find the y-coordinate of the vertex, we need to plug the x value into the original equation. So what was our given a while ago? I know, it's the different one. So you have there, say for example, you have negative 2x squared plus 8x minus 3. So the same thing for, let's plug in the line of symmetry. Our opposite of b is 1. Right? That's the opposite of b, that is positive 8. Therefore, we have negative 8. Now, our a is, what is our a? It's negative 2. Therefore, 2a, that will give us negative 8 divided by negative 4 is equal to positive 2. So there you go. Next, plug the x value into the original equation to find the y value. So we have the value of x already, that is 2. So you have there, what's our original equation? That is here. All of the x becomes 2. Therefore, 2 squared plus 8 times 2 minus 3. So you have there 2, 2. So let's solve the problem. Exponent first. So you have negative 2, 2 to the power of 2. That is 2 to the power of 2, that is 4. And now it's have negative 2 times 4, it's negative 8, and 8 times 2, it's 16. Minus 3, and negative 8 plus 16 minus 3, that gives us y equals 5. Therefore, the vertex is 2, 5. How did we get 2, 5? Our 2 is our x, and our y is 5. Y is 5, and our x is 2. Therefore, our vertex is 2, 5. Now, we're done with line of symmetry. We're done with the vertex. The next thing that we have to have is this one. What is the important thing to have a graph? We need a table of values. But before that one, let's have this one. Again, let's just have a quick recap. The standard form of a quadratic function is given by y is equal to ax squared plus bx plus c. There are 3 steps to graphing a parabola in standard form. First, you find the line of symmetry. Let's go back. So sorry. Okay. So there. Find the line of symmetry. Use the equation x is equal to negative b 2a. Second step, find the vertex. Plug the line of symmetry x value to obtain the y value of the vertex. And step 3, find two other points and reflect them across the line of symmetry, then connect the 5 points with a smooth curve. Make a table using x values close to the line of symmetry. So let's graph. Let's graph one. Let's try. So say for example you have there y is equal to 2x squared rather. Y is equal to 2x squared minus 4x minus 1. Let's have to find the symmetry or line of symmetry. So now that we have that line of symmetry, we are going to use the formula x is equal to negative b over 2a, or I will say it opposite of b over 2a. So we have there, what is our b? That is negative 4. So what's the opposite of b? That is 4. And now, let's copy the 2, and our a is what? It's here. It's 2. Now let's solve the problem. 4 divided by 2 times 2, that would give us 1, because that is 4 over 4, and that will give us 1. So we have the line of symmetry is x is equal to 1. Where is it? This is our 0, so this is our 1. That's our x-axis. Therefore, this is our line of symmetry. Next, we have the line of symmetry. Let's have the vertex. Since the x value of the vertex is given by the line of symmetry, we need to plug in x is equal to 1 to find the value of y, or the y value of the vertex. So we already have x is 1 as what has been shown in our step 1, that our line of symmetry is x is equal to 1. So let's plug x is equal to 1 to the original equation. So all of the x becomes 1. So therefore, that becomes, over here, that is 2 times 1 squared minus 4 minus 1 minus 1. Right. Why did it become negative 3? Because you have there 2. 1 squared is 1 minus 4 minus 1. And that will give us 2 minus 4 minus 1. And that will give us 2 minus 4 is negative 2 minus 1 is negative 3. Okay. So we already have our vertex, which is 1, negative 3, because our x is 1 and our vertex is negative 3. Again, where did we get this one? Our x is from the line of symmetry, that is x is equal to 1, and our y is equal to negative 3. Okay. So that is our vertex, 1, negative 3. It is being placed there. The next step is you're going to graph 1. So find 2 other points and reflect them across the line of symmetry, and connect the 5 points with a smooth curve. So say for example you have x is equal to 1, right? So we are focusing on the right side of x, that is 2 and 3. So if our x is 2, look at here, if x is equal to 2, that one is from the original equation. We make all x as 2. So 2 times 2 squared minus 4 times 2 minus 1, that will give us negative 1. Oops, that's here, I'm sorry. And if our x is 3, our y is, right, there is 2, negative 1. If x are 3, our y is 5. Okay, just to make things clear, that is negative 1, and this one is 5. So this one is 2, negative 1, and this one is 3, 5. So, are we done? We're not yet done. The parabola has not been properly plotted yet. So, what are we going to do? Find two other points and reflect them. So, what are the other 2 points? That is, since this is the line of symmetry, they both have the same value of y, and that's the distance of 1. This one, they have a distance of 2 from the line of symmetry 1 and 2. That's the line of symmetry. So after that one that is being reflected already, we now have the parabola. Okay? So let's just have a quick recap about that one. So, sorry. So the direction of parabola depends on the value of our A. That is, if A is positive, then the graph opens upward, opens up. And if A is negative, then the graph opens down. So find the vertex and axis of symmetry. The x-coordinate of the vertex is x is equal to negative b over 2a. That's also the equation for the axis of symmetry. And then substitute the value of x into the quadratic equation and solve for the y coordinate. Now, write vertex as an ordered pair x1. And the last step is have a table of values. So choose 2 values for x that are on one side of the vertex, either right or left, and then substitute those values into the quadratic equation to find y values. Then graph the 2 points. Graph the reflection of the 2 points, I'm sorry. Again, graph the reflection of the 2 points on the other side of the parabola. It's same y values and same distance away from the axis of symmetry. Now let's have an example here. Find the vertex and axis of symmetry of the following quadratic equation, then make a table of values and graph the parabola. So you have there our direction. What is our direction? Our A is 2, and A is greater than 0, therefore it opens upward, right? Up. Now, vertex. What is our vertex? Or let's have first the axis of symmetry. So, axis of symmetry here. Axis of symmetry. What is our value again? It's x is equal to negative b over 2a, or opposite of b over 2a. What is our b? That is positive 4. What's the opposite of positive 4? That would give us negative 4. And 2, copy the 2. And what's the value for a? That is 2. So that would be 2. Now, negative 4 over 2 times 2 is 4. Therefore, our x is negative 1. Our axis is negative 1. Now, let's plug x is equal to negative 1 to y. So, we have there y. What is our y? We have there, sorry, that is 2. Our x is negative 1 squared, that is from here, okay? As x as negative 1. X is negative. So x is negative 1, then therefore 4 times negative 1 plus 3. That is 2 times 1. Oh, sorry. That should be negative 4 plus 3. Because 4 times negative 1 is negative 4, so therefore we have 2 times 1 is 2. Positive times negative, it's negative, and plus 3. So you have that 2 minus 4 is negative 2 plus 3, that is 1. 2 minus 4 is negative 2 plus 3, that is 1. Therefore, our vertex is 1 and our y is 1. Right, it opens up. Our vertex is 1, 1, and our axis is x is equal to negative 1. Are we done? No, we're not yet done. So we are going to find the table of values. The area is 1. Okay, let's do it again. What we had is direction is up. Our vertex is 1, 1. And our axis of symmetry is x as, oh sorry, our vertex is negative 1, so that is negative 1. Now, let's have the axis that is negative 1. This is our axis of symmetry, negative 1. Again, axis of symmetry, x is equal to negative 1. Our vertex is negative 1 and 1. So that is our vertex. This is our vertex. Now let's have the table of values. So our x, so let's just choose one side. That is 0. Right, right side that is 0, and here we are choosing 0 and 1. 0 and 1. So if we say y is equal to our x is 0, so 2 times 0 squared plus 4 times 0 plus 3. So you have there 2 0 squared is 0, and plus 4 times 0 is 0 plus 3. That will give us 2 plus 0 plus 3, and that is 5. So that is 5. Next, what is the value of our x is 1. So y is from here, okay? You might be wondering. So that is 2 times 1 squared plus 4 times 1 plus 3. And that will give us 2 times 1 squared is 1 plus 4 plus 3. And 2 times 1 is 2 plus 4 plus 3. So you have there 2 plus 4 plus 3. That would give us 9. So let's have this one. So if our x, again, if our x is 0, our y is 5. So 1, 2, 3, 4, 5. And if our x is 1, our y is 9. 5, 6, 7, 8, 9. So that is our graph. Now let's reflect now on the other side. So here, on that side, it's 1. The distance is 1, therefore the other point that is being reflected through the line of symmetry or axis of symmetry is here. And let's go to the other side. The distance is 2. So let's have the distance of 2 also, and that would be the point. Now we already have these 5 points. We can now graph the parabola. So that's our parabola. Next, let's have another example. Again, what is the value of our A here? We have negative E here, so that should be negative 1, right? So the direction should be down. Our vertex and our axis of symmetry, let's have this one. Axis of symmetry, or the vertex of y, it's the same thing, so let's have there x is equal to negative b, or opposite of b equal to a. The opposite of b is we have b of 3. So that is opposite of positive 3, that becomes negative 3, 2, and a, our a is negative 1. So look at here, that becomes negative 3 over negative 2. That would give us positive 3 over 2 or 1.5. So our vertex here, or our axis of symmetry, is 1.5, right? Now, let's go to the vertex. Oh, our axis is x is equal to 1.5. So it's down. Alright, let's have the vertex. Our x is 1.5, right? So let's plug it into the original equation that we have here. Negative 1.5 squared plus 1.5 minus 1. Alright, so we have there negative, and then 1.5 times 1.5, that will give us 2.25 plus 3 times 1.5, like this, 4.5. So negative 2.25 plus 4.5 minus 1, that is 1.25. So we have here y is equal to 1.25. So we already have the value of x. Our y, therefore our vertex now is 1.5 and y as 1.25. Alright, let's have that one. Let's graph it. Let's plot it in the coordinate table. So our axis is 1.5, so that should be between here, right? So this is our axis of symmetry. And our vertex is 1.5 and and our y is 1.25, so it should be somewhere here. Therefore, our vertex is somewhere here. Because this is 1, this is 1, and 1.5 is between 1 and 2, and 1.25 is between 1 and 2, but it's nearer than 1. It's nearer to 1. Next, let's have the table of values. Let's just have the x and y. Let's just say that Let's have 3. Let's have 3 and 4. Let's have 3 and 4. So let's have 3 and 4. Let's plug it in. So if our x is it's 3, so it's negative 3 squared plus 3 minus 1. That is from here. Okay? That is negative 9 because 3 squared is 9 plus 9 minus 1, so that is negative 9 plus 9 minus 1, that will give us negative 1. Okay, so let's plug it in. If our x is 3, our y is negative 1. So there you go. Negative 1. Now, if our y or our x is 4, so that would be y is equal to negative 4 squared plus 3x minus 1. So that would give us what? Negative 16 plus, oh, I'm sorry, this should be okay, that is y is equal to negative x4 squared plus 4 minus 1. So you have there negative 16 plus 12 minus 1. So negative 16 plus 12 is negative 4 minus 1, and that will give us negative 5. So if our x is 4, our y is negative 5. So this is our 4. 1, 2, 3, 4, negative 5. And let's reflect it from the axis of symmetry, that is the distance 1/2 and 1. So that is 1/2 and 1. So therefore it's here. And the distance is 2.5. So half, 1, 2. So there's also the other one. Therefore, our parabola should look like this. You can pause this one and review. Okay. Now let's go to your partner. Do not forget to turn it in to your teacher for this activity. So if you have questions, you can always ask me. I'm just here. So that's all. Thank you.